my first presentation on any of the meetup talks. I've done a couple lightning talks in the past with the CodePen meetup and with Orlando JS as well. In this talk, I'm going to giving you an overview of SVG, Canvas, WebGL, and also CSS, kind of how it works, practical use cases of it, and performance considerations you need to keep note of. So let me tell you a little bit about myself first, in case you're kind of wondering what my background's like, professional and programming-wise, since I haven't really explained it in much great detail. So I got my Bachelor's of Science in Materials Science Engineering at the University of Florida in 2013. Most of the research that I did was actually on metallurgy, so the study of how metals work on the atomic level. My thesis was on shape memory alloys, so just how they form, how they change over time. And you'll actually see those materials in things like glasses, like these, braces. You'll see it actually in the Mars Curiosity rover's wheel. So that was kind of the work that I did at school. I ended up doing some work at a fertilizing company for a bit, doing some mechanical analysis on their giant dryer, which is kind of like the dryer you have at home, except much bigger, right? And it's continuous. You don't put a cycle in and then close it off, turn it on, and then run. This thing runs all day. Kind of went away from that. I got hired by the Nuclear Regulatory Commission for a bit, but I couldn't pass security clearance because I'm a dual citizen, so that didn't work out. Ended up moving away from all that. Ended up actually designing restaurants for a living for the last few years. So completely different change of perspective. I've had the opportunity to work with a lot of great people. This is actually the head chef that trained under Matsuharu Morimoto from Iron Chef, and that's at Morimoto Asia. So I get to work with a lot of high-profile clients, just both domestically and internationally, mostly in the Asian theme restaurant theme. And yeah, so that's my professional work experience. You might be wondering what my programming experience is like. So I started off programming actually writing extensions for popular programs like Airtable. It's a relational database system. And I wrote a popular Excel VBA script. And then I also wrote popular extensions for note-taking applications, CSS themes and Chrome extensions that I use every day, kind of to short cycle the amount of time it takes for me to learn something. And design background, yeah, I'm just skipping through all that. I just want to get it over with. So that's enough about me. So just kind of disclaimer, I'm not an expert on any of these topics I'm going to be presenting. I did the best I could in trying to actually portray the information as accurately as possible. I'm going to go over like the fundamentals of the topic, and as well as a high-level overview of what things you can do with it. That way you get a better appreciation of what things you can do. So really just why should you care about this talk, right? Or this topic in general, right? Just kind of take a step back for a moment and just think about the times before we had the web, right? We didn't have Facebook, we didn't have YouTube, we didn't have all these great things that we have today. We kind of take it for granted today, right? And communication back then was really difficult, and the web just made standards so much easier, right? And you take a step forward today and you look at all the great software that's out there and kind of paving the way and making things much easier to understand, much easier to learn new concepts, to messaging people across the world, to solving different problems that you might have at work or for personal life. And really, I had that backwards, unfortunately, but great software solves problems, right? And really at the pinnacle of everything is the ones that do it best have great UX design and animations, right? And really mastery of that field requires knowledge and SVG, Canvas, WebGL, and CSS. And also, by having a better understanding of these topics, it'll also open up more opportunities down the road, either you as a developer or you as an actual agency. If you're looking to look for clients that are willing to pay more for better work, to build next generation tooling, this is something you should be aware of. So let's go over SVGs. SVGs are scalable vector graphics. So It's a graphics format that's kind of the go-to solution right now for icons, logos, and many other graphics web applications as well as mobile apps. Um, it's extremely popular today, but you would think that um, this was actually new technology, but it's actually not. The W3 standard actually established it in 1999, but the support for SVGs has gotten much better today, so that's why it's becoming more mainstream. So why are they so popular, and why should you care about them exactly? It's really in the name, scalable vector graphic, right? Scalable in the sense that you can render at any size and resolution, like on this big screen. This isn't actually a vector though, so kind of have to point there. But you can render it at any size and resolution. So on a big screen or just something really small like this, and it'll still look really crisp. It's comprised of vectors drawn with strokes and fills. So, and it's also a graphic because SVG scalable vector graphic. So kind of tailoring to that, comparing it to other types of things that you can do on the web. So JPEG, PNG, and GIFs, they're all bitmaps. You represent data on a pixel grid, right? And on that pixel grid, you have a predefined height, right, and a predefined width. And this could really greatly vary across different browsers that you're working with or your mobile device. And it becomes inefficient if you have, say, like a really big image and you're serving on a really small device because now you're using much more server resources in order to load that data to your actual phone. Or vice versa, if you have an image that's suited for your phone, you're loading it on a website, it'll get really blurry and choppy and no one can really see what's going on. So with that in mind, SVGs are much better in that they're actually based on vectors. So you define a point, you define another point, and you define how that curve should look. So by doing this, you tell the browser essentially what should actually appear on the screen, and the browser is smart enough to actually draw it on any device and scale to that appropriate shape and size. And it doesn't matter if it's on this big screen or if it's just on your phone, it'll look good anywhere. So that's kind of the benefit of using a scalable vector graphic. And there's really much more. They're actually native markup documents that live alongside with your HTML elements. So one of the core benefits of that is they're actually styled the same way as your div elements, as your body element, as your section element, as your paragraph element, your span. It's all the same. It's treated the same across all browsers, which allows you to manipulate it in any shape, way, form, or any way, shape, form you want, either with CSS or JavaScript. And really, because of that flexibility, you can do pretty much anything with it. So it's the standard graphics format. It's not limited to just web use. You can create and edit SVG in Sketch, Adobe Illustrator, etc. And kind of just to get a better appreciation of it, yeah, it's an open format. You can use it anywhere. I'm going to actually showcase how you would actually use it in production, how you'd actually create the graphic using an actual editor. I'm going to be using Figma, which is a UX design tool, and then port it over to actual code and then load it on CodePen. So what I'm going to be creating today is this logo. You guys know what this is? Anyone? It's the Mac command bar. So I'm going to be making that. I'm going to make it in Figma, which, who here is familiar with Figma? Heard of it? Do you want to explain what it is?
Yeah, for us at Showflow, we actually use it for our designers. Designing prototypes to build out our design system in it, to have reusable components for it. So it's kind of a replacement for Sketch, but designed for the web. Yeah,
it's like Apple Sketch, except Windows users can also use it too, which is great because unfortunately all the design tools are based in Mac, and Windows users are kind of left in the dust. So I'm a heavy Windows user, so that's why I use Figma. Kind of some of the other shapes you can make. You saw the rectangle that we just made earlier. What you do is you define. So let me just go through an overview of like the most common shapes and how they work. we define an x and y coordinate grid, or sorry, an x and y coordinate, and that's based off the point at the top left of the canvas, not the canvas, the frame, right? And x goes up this way, and y goes up this way. So it's kind of like a reverse coordinate grid, if that makes sense. This is kind of the different ways you define it. So in this case, you define the stroke right here, the width of how big it is, and the height. And then you can also define circles, polygons, lines, in which you define your actual coordinates on the actual plane. And that corresponds to the actual shape. So moving on from here, there's 3 ways to use an SVG. So the way I just showed it to you previously when I made that drawing and then exported it off and then imported it into the CodePen, that's called an inline SVG. So it actually lives adjacent, it lives on the same level as your other HTML DOM elements. The other thing you can do is embed it as a CSS background, like as an actual property. So let me show you how that works. I'm going to comment all of this all out. Actually, I'm still learning how to use a Mac. Comment all that out. I'm going to set another div element. Let's just say this is, just call this filler. Actually, it's supposed to be lowercase. Filler and filler. And in that class, we'll define a height of 200px, width of 200px, and then I'm going to go under the assets in CodePen. This is something cool that you can do in CodePen. I don't know if you're familiar with it. If you go to patterns, this pulls up different hero patterns I can use for different website applications, and it's just an SVG backdrop that you can throw on anything. And when you copy it, it gives you the actual embedded code that you can throw on your website. So this is another way of actually representing an SVG. And you actually have to use a tool online usually to convert it from an inline SVG element to an actual embedded SVG. But in this case, you can see it working right here. So let's go back to the main page, and there you go. It's right over here. That's how you make an embedded SVG. The last way of making an SVG is to reference it as an image tag. And if you do any React development and you do create React app and you get that React logo popping up, who here does React development? Okay, a lot of people. You've probably seen it already, but let me show you how you do it. How you would do it with just a pure image tag. So let me comment this out. Now I'll just reference another thing, source, and right here. I had it uploaded already, by the way, so that way wouldn't have to go looking for it. So yeah, you can reference it as an actual image element. So there are downsides when you either embed it as a CSS background or an image source, namely in the sense that you can't have individual elements to select on the page. So let me show you that. If you actually run it through the DevTools in Chrome, this is only one element, right? And the same is true if you run it through that filler element as well. This is also one element too. But with the original command bar logo that we created, what is this? I can't select. So with the original command bar that we created right here, and let me kind of blow up the image so it's a little bigger. All right, that's a little too big. 500. Okay, if you actually run it through the debugger, you'll actually see the individual items. So you can actually work with each individual part if you're actually applying CSS to it. So, and just like any other HTML element, you can apply classes too. So we'll just call this test class. These are really bad names, but test class, and you could say fill red. There you go. So just like any other HTML element, you can also apply properties to it. You could say the stroke is blue, or we could say green instead, and it should work. Yeah, it works. So that's one way of doing it. But let's say you want to actually fill everything, right? You don't want to apply a class to each element because that just takes forever. And it's also not as robust if you have to apply it every time. So what you can do is you can actually set a grouping to everything that you're working with. So you could say G, which means group. It's actually very similar if you're working with any design programs, which nobody really uses. Like when you're working with Figma, you can actually group elements together right up here, right? What I'm doing with the code on the other end is more or less the same thing. So you can group up those elements, and you can actually fill everything up all at the same time. So let's say it's purple, and it should work. Oh, I don't know what happened here actually. What happened here? Oh, I grouped everything. I should have just grouped this part. There you go. It works, except this one obviously I called first, so it gets overridden because it's a higher CSS specificity. Yeah, so that's an example of how you can actually apply CSS over to an SVG file. And other things you can do with it, moving on with the presentation. Oh, so actually before I get into that, actually let's go into that first and I'll come back to the file. Who here has seen this? If you ever go to the airport, the Orlando airport, and you go through the security line or go to the bathroom as well, you'll see one of these things, right? And this is just a smiley face with different states. That frowny face, partially smiley state, and then happy face, but no neutral state, right? The good thing, I guess they really want you to make sure you're actually happy or not happy, and they don't want you to just be neutral, just put neutral. So, yeah. So one of the great things about SVG is you can represent as many states as you want. You can have smiley face, you can have frowny face, and you can pause the animation at any point in time. And this is only possible with SVGs. You can't really do this in pure CSS. With CSS, you'd actually have to animate the entire frame, but you can't pause it at any point. But with SVGs and actually manipulating the path element inside of it with JavaScript, you can do whatever you want. And kind of showcasing how this all works, how this code is actually represented on HTML. You first define your circle, right? Your smiley face right here, and then these are the associated properties of it: the radius, the stroke, and the fill. And that's that part. And then you define your eyes with this right here, and those are just more circle SVG elements. And this you can usually write by hand. It's pretty simple and straightforward to figure out, even if you don't understand any of it. But then when you get over to the actual smile part itself, it gets a little more complicated, just like in the original thing that we created, the command logo. It has all this weird metadata associated with it, and you might be wondering, what is that? And if you're working with SVGs often, you're going to have to understand at least the basis of what this is, because if you work with any design program, or if you're working with a designer, they're going to send you gibberish code like this. Like, you'll just see a lot of gibberish code. It might be this many lines, but in reality, it's probably like this many lines, right? Kind of like what you saw earlier with that logo I created. And really, what it is it's kind of like machine code almost. It's actually cubic Beziers, and to describe it a little bit better, I'm going to show you a tool that kind of has like a playground element to it that you can actually experiment with to see what it looks like. This is a tool that was created by Anthony Dubois. So kind of let me showcase like what it is and how it works and how to use this information right here to understand how the SVG gibberish looks like. So let me just reset the. There's a couple other things. You can use this thing called Q, which is it'll just be easier to show you. It's like a curve point that you can set, and you can see the data changing from here. Your coordinate pair is still the same that you're starting from, and this part defines that coordinate right there, the amount of curvature.
Is that some kind of pixel value, or is this?
It's actually a unitless value. So, I'm trying to remember how to explain it. What those numbers mean? You're defining like a workspace, right? When you're working with your SVG is so big on the screen, and this describes kind of the position of where that SVG part of it is located. So I think that's. I'm not really entirely sure, honestly. I'm not an expert at this. It's actually quite complicated, but I want to show you kind of the rest of them. This is the cubic Bezier. That's the smiley face that you saw earlier. So you can make a smiley face, right, and then a frowny face. Oops, sorry, and you can see the coordinates change. So right here, that makes sense. And there's one more. There's the A tag, and that just sets like a semi-hemisphere. Whoops, sorry. All right, so I just wanted to show you what that looks like. That way you get a better understanding of what that gibberish looks like, kind of playing around with it. Let me go back to the original page, the original slides, zoom out. So yeah, kind of everything I just described here, I just showed you in actual code. If you're working with SVGs often, this is something you should just be familiar with. That way you understand where that metadata is coming from and what the machine or what the computer actually understands. So if you're animating things with SVGs, there are a lot of different libraries you can use out there. You can write it natively in vanilla.js, but you'd have to write at least 100 lines of code, which nobody wants to do. So most people just recommend to use the library. And if you look at any guides online, there aren't any guides of how to actually use vanilla.js, except the one I showed earlier. So 3 things that are specific to SVGs for animation. You can have motion on a path, and you would actually use JavaScript to actually animate that as opposed to CSS keyframes. You can also morph different shapes. So what you do is you set your starting state of what the actual SVG looks like, and then the ending state of what it should end with, and you can morph into the appropriate shape. And then the last thing is animating the whole fill line in the stroke itself, and that's how you would specify that. So just to go over all the ways you can animate it, have you guys seen that logo before? Has anyone seen it? GitLab. Did you know that GitLab has an animated logo? Who here knew that? Who here didn't know that? Yeah, so if you go on GitLab.com, and you can go on your browser or your phone right now and you actually log in, and you go to the very, very top left of the page, and you hover over that icon, that little tiny icon, 50px by 50px or something like that. It's an SVG, and it scales to any size. They just kept it small just so they can animate it when you hover over it. It's a nice subtle effect, and this is something that SVGs are only capable of, right? Because you have 7 different DOM elements here wrapped in one SVG tag. The next thing you can do to animate SVGs is apply keyframes. And I don't think I showed that earlier. Maybe I did. I didn't. But this one just shows it growing. You just set your keyframe at the bottom, the name of it, the properties. In this case, transform scale until it grows out to 50% of its size, and then the duration of it. And the last thing is using JavaScript to manipulate the actual metadata associated with your SVG. So this gives you the full flexibility of doing whatever you want with your file, having any number of animatable states and pausing at any point in time. So you define a starting state and ending state, and then you generally use a library, or you can do it with vanilla.js. I have an explanation of how this works if you want to see it later. And then there's also a fourth way, but no one really cares about it because it's getting deprecated. So just FYI, I'm not going to explain what that is. Also, who here is familiar with After Effects or knows what it is? Okay, what is it?
Picture.
Anyone want to answer?
Picture manipulation. After you take like photograph, people that work with photographs, they use it a lot.
Well, that's Photoshop.
Or
After Effects. Composition, definitely.
Animation.
Yeah.
Animation.
Keyframes and-
Keyframes. So if you ever watch YouTube channels like Corridor Digital or Freddie W or any other popular YouTube channels out there where they do really cool special effects, this is all based off of After Effects, right? And Airbnb created a plugin based off After Effects to actually take whatever you make in that program and translate it to the web. And this is something that only came out in the last 2 years, so you might not have heard of it. You may have, I don't know. And let me showcase what it can actually do. This is code generated from After Effects with a plugin, and then you're just pasting whatever comes out of it. And if you look through the actual file, there's really not much. There's a ID container, right? You've got a little bit of CSS, not really anything, and your JavaScript file is only this long, so you might be wondering, where does all this stuff come from, right? With After Effects and Lottie, after you finish creating and compositing your entire scene and how it should interact in that program, you actually reference an actual JavaScript file specific to the application that you made, and they actually have like a CDN specific to your user tag, right? And the username for whoever created this is actually, I don't know who it is, but yeah. So that's a really cool thing that you can actually do. Here's another example. So another really cool example. I don't even know how you would even begin rationalizing how to create that because I'm not that good of an artist and I suck at animating. But you can kind of see visually all the great features that you can have with this plugin. And you don't have to write any code at all. You literally just paste some CSS, and it's very short, very minimal. It's probably the same CSS you use in another file too. And like I said, HTML, very simple. JavaScript is really nothing. Yeah, so it's great. Another tool that you can use if you're a terrible designer like I am is you can actually, there's a WYSIWYG editor, it's kind of like a UX design tool like Figma, except it has built-in animation support. And it's called SVG Gator. It came out in the last year. It's very new, but it was on Smashing Magazine and a couple other big CSS publications. This tool is only good for a one-time CSS animation, so you can see all the code right here. It's a lot of minified gibberish. And there's a style tag starting right here, so you know it's just a keyframe animation. And this is just all code generated from it after you design it. And then you have your actual SVGs right here. So to actually demonstrate what it does is if you're signed up for a newsletter and you want to showcase like a cool animation after they sign up with their username, their name, and then the email. Right? That's my email address, by the way. All right. Yeah, so really cool stuff. Once you run it one time, you can't run it a second time, unfortunately. So that's kind of the downside to this. I don't know why it has some weird squiggly things at the very end, but yeah. So just an overview of everything animation related, because if you're looking at SVG animations or just animations in general, these are all the major comparisons that you can think of, and also the size of those files. In case you're having a site that has a lot of traffic, you want to make sure you're at the smallest size possible. So if you write a native SVG, just either hand code or with a design program, and then manually clean it up, and write your animations from scratch either with a library or with keyframes, you can get a very small size that's very performant. So for a high traffic site, this is great. You don't have to make as many HTTP requests. You don't have to load as many assets, which is awesome. GIFs kind of range really anywhere from really small sizes to really humongous sizes, depending on what you're working with. And one thing that's great about GIFs, this is actually a GIF, by the way, it's not doing anything. You would think it's an image, but if you reload the page, you can actually see it playing right here. You can see it playing right there. And this is also a great way if you want to showcase to a client, or if a client wants to have something animated at the very start of their splash page, you can have this run, and then it kind of stays static afterward. With Adobe After Effects and Lottie, I ran a couple of tests to see how big those files would become. The one that had more animatable graphics came out to 241 kilobytes. And depending on how big your project is, or depending on how many of these, you're going to have one of these per animation that you have, right? With SVG Gator, the size is much smaller, and it's also a one-time CSS keyframe, so it doesn't animate more than one time. Kind of moving on, or actually, let me showcase some cool effects with SVG. SVGs can actually apply blurring motion as well, and this is good if you're making an image and you're applying a filter on top of it. So let's say you're on Instagram, you're saying, hey, I want to have this picture kind of look retro red or something, or whatever filters you put on your images. You can have an SVG layer that's on top of it, and then that can actually apply whatever image filter you want. So, and you can kind of see that effect here when you see a blurring when the Earth is exploding. This is all written with SVG. Both the actual animation of the little lines between different continents, and then also the explosion. So, kind of more examples. Who here has heard of D3JS? One person. Okay. Do you want to explain what it is?
It's a library for manipulating graphics and JavaScript.
Yeah, that's true. I mean, it's like everything, right?
More like charts and stuff.
Yeah, exactly, for charts. Data visualization is really big in SVGs. If you ever use D3JS, which if you're working with a stock trading app, if you're working with anything that requires a lot of data to be shown on the screen, D3JS is based entirely on SVGs. So this is some examples, and this kind of gives you a good overview of what it can actually do. I'm not going to open up the pages, but you can kind of get a visual representation of what it's capable of. So yeah, that's definitely cool. Who here has heard of MIT Scratch? Anyone? Yeah, it's a programming language, right? It's for kids, and also for adults too. If you're trying to learn programming for the first time and you don't want to actually code anything, you just want to do drag and drop and place Legos everywhere. So, oh, I'm not signed in. Darn. Actually, okay. All right. So let's say you're over here. Well, while that's loading, let me show you the next part. Flaticon.com. This is something you should be familiar with, since no one here knows how to design except one person. This has the largest library of vector file assets you can download. And you can use this for both Adobe Illustrator, for just doing things off the web, and you're making something like catalogs, for making brochures. You would use something like this. So let's say we're trying to look up a Facebook social media icon. There's 459 matches. So you can pick any variation of this. And you can click on the icon. Oh, actually, maybe there's other better icons, and you can actually download it straight from here. You have to credit the author though, but no one ever does. But just FYI. Scratch didn't load up, so let me just ignore that. We'll come back to it later. So, moving on, let me talk about HTML Canvas. Who here has heard of HTML Canvas? Like 5 people, right? Do you want to describe what it is?
Sure. It's basically kind of like a div and HTML in which you can place images, and it's very nice for manipulating, like actually like putting a background and being able to manipulate for say like character. I've mostly been playing using it for a game right now.
Okay. So yeah, you can use it for like a side-scrolling video game.
Right.
That's one application. Do you want to say something, Dwayne?
Well, from what I understand, it doesn't like block the main thread. It kind of like has its own.
Yeah.
Where it's you can do a lot more with it, so it's more performant, I think. So because it doesn't like block.
Well, you're learning Matter.js, right? Matter.js is based off HTML Canvas. How it draws things on the screen is all based off this technology.
It has its own thread, I think, or something like that.
I'm not sure about that, but probably. That makes sense. I don't think, is JavaScript multi-threaded? I don't remember.
We have like work and stuff.
I can't remember how it works, but that's something I drew. Does anyone recognize this? Who here shops on Amazon? That's actually the Amazon loading banner right before you're checking out. I actually took all the image assets from that page, and I threw a canvas element overlay on top of it, and I put it on CodePen, and I got like 3,000 views. That was great. So HTML Canvas, what is it? It's an HTML spec created in 2011 for drawing graphics on a screen. So kind of like what everyone stated, you can do a lot of cool things with it. You can write games with it. You can do things like, well, after I show you this, you can do things like this, which is like the hello world of Canvas. You draw a border box around the entire screen. You draw a circle, and then you can animate that circle. And that kind of showcases what Canvas is capable of. So just think of your traditional 2D scroller off whatever website you're thinking of. You can use Canvas to power that. And it gives you a representation of actually having real-time physics as well. So just kind of how it works. The code is very short. Essentially what you're doing is, oh wait, that's weird. It lined up perfectly on my computer, but I guess this computer is different. So, the first thing you do is you actually create a canvas element right here, right? And then before you select it, so you're actually selecting that DOM element, and then you specify its width. And from here, this is window.inner width, and this is window.inner height. And then you specify a variable to get the context of that selection you made. And then from here okay, well this is all messed up. From here you actually define your parameters, like what this circle is, how big is it, that's the X and Y value, and I just use a random size depending on how big your screen is. And then you set your velocity, both in dx, dy. So, like I said earlier with SVGs, your XY coordinate plane always starts from the top left. X is this way, Y is this way, right? So, you set that right here, and the way it's set up, when you use math.random, it gives you a number between 0 to 1. So, you have a 50% chance of having a number that's higher than 1, and higher than 0.5 and a 50% chance of having it below 0.5. So depending on what you get out of it, changes your initial direction. So if you reload the page, you can see it's now slightly faster, right? Every time you reload the page, it has a new initial value. And you set your radius, you actually animate the actual circle, and what you do is you request an animation frame, and what that does is it redraws a circle every time on the screen, and then you clear the original results that you had. So to kind of showcase what happens if you don't clear the rectangle every time you animate it, it'll give you a better appreciation of what's doing behind the scenes. So if you go on this page, you can see it's much slower now because it's all randomized. If you go back on this page and you set this off, right? And you save it, it's going to look like that. So that gives you an idea of how it actually works. It's kind of like a slinky, but maybe this is the effect you want. Maybe it's not. It just depends what you're trying to do. So for most people, they usually have a clear rectangle, and that clears the entire rectangle right here, right? The entire viewport. And kind of the best way of learning things is you just break them. You just take someone else's existing code and you just destroy it, and then you get a better understanding of how it works. So let's see, and then you have an update function, and let me show you what happens when you don't update the values associated with it. If you turn it off, it just stops moving. So what happens is you're calling the animate function right here. You start initializing it here, and then it calls it, and then it continuously calls it every time. So it's on a constant loop, and it's constantly updating your dx value, which is like your speed at which you're moving, and your dy value, essentially if you hit like the edge of the screen, and also your coordinate positions. So that's kind of just like a little overview of how, or kind of like the hello world of HTML Canvas works. Kind of moving on from here, just some of the cool things that you can do with it. This is something I wrote with just HTML Canvas. It's a box, and it's got a vanishing point at the very back, and you can see right here what's going on. You can set the different parameters associated with it and actually change the shape of how that box looks. And this is all done with HTML Canvas. So you can represent 3D objects on a 2D plane just with a little bit of math behind the scenes. All right, so is anyone familiar with this? Let me play it. Does anyone recognize this? Yeah, it's like the $1 million homepage, but does anyone recognize it?
That's like the, I don't know what it's called, but it's like this big, basically this board that we're going to like all the Reddit reading this thing.
There you go, you're right.
I don't remember what it's called.
So April Fools on 2017 in Reddit, they posted something on the top of the front page saying, hey, you can go join the subreddit and you can put a pixel on the grid. And 90,000 people put pixels on the grid constantly for 72 hours straight. And that was over the course of 3 days. I was actually one of the Reddit monitors, believe it or not. There's only like a couple of them. But I did all the documentation for that process. So it was horrible. There was 30 people documenting the entire process of every war that went on between this circle and that circle and Darth Pegasus the Wise and all that, and I annotated 1,000 images for that. I don't know why I did it, but yeah, fun fact. If you want to see what this actually looks like in a representation today, a CodePen user by the name of Steve Gardner, he's really well known on that site. Here's an actual representation of what you can actually do today. So I'm logged into Twitter, and he purposely set it that way so you don't DDoS the site. You can set a parameter, and you can put a point in the map. And you can set another value, you can put another point in the map. And this kind of showcases the power of HTML Canvas. And this is something that's not capable with SVGs. So with SVGs, you can't like enhance all the way down to like this finite size. You can't see that fine level of pixel value. So really cool. This is a 1000 px by 1000 px canvas grid, and it's so the way canvas works is it has its own width associated with it. Then it's got actual width of like the size it takes of itself. If that makes sense. Like this isn't necessarily 1000 px and 1000 px on the canvas, but internally it has a grid of that size. I don't know if that makes sense. So I'd have to show like how that works, but essentially it has its own width parameter on top of being a traditional DOM element on the HTML side. So you have your canvas element, and you can set how big the canvas element is. So let's say I go edit it on CodePen, and I say something like canvas width of 300 px, and then I run it. Well, I guess you might have to say important. Yeah, so, but it's not truly 300 px wide, right? You know the canvas is 1000 pixels long. So it's got its own parameter associated with it, if that makes sense. So there's technically a width value associated with canvas, the element itself, and then internally it has its own grid system. Kind of moving on from here, let me showcase other things you could do with canvas. This is a popular indie game called Celeste. I don't know if anyone plays indie games, but yeah, got a couple people here that knows what I'm talking about. This is probably the only, like, this is like the best 3D representation of what you can do in canvas. This is like the limitation and extent of what you can do in that regard. So you can actually drag this around and visualize things in 3D. And the way this works is a lot of math, which I don't really want to get into, but you can kind of see it's very long. So really, that kind of brings me on to my. That kind of brings me on to my next point. The canvas. A lot of people get confused on what the canvas actually is. It's literally just a rasterization API. So it's literally just pixels on a canvas. Like think of like an artistic canvas, right? If you're drawing on like an actual canvas, if you're saying, let's say you're watching Bob Ross on TV, back in the day, and he's drawing on an art canvas, that is a canvas, right? You can represent things 2D, or you can draw it 3-dimensionally if you're really good at things like perspective and shadows and vanishing points and all this other art stuff. But this is the same thing. If you're good at math, you can do really cool things. I suck at math, so I can't really do that. And some other cool things. You can have like a matrix background. And these are actually all Chinese characters, believe it or not. And the way this runs is you actually have something called bar Chinese, right? And this is all based in UTF-8, I believe, or UTF-16. I don't know. It's one of those. You can type Chinese characters on the web using an IMU keyboard, but you can do it here, and you can actually render it on the screen using Canvas. So that's pretty cool. Maybe you want something on your splash page or portfolio page, and you want to have this cool thing in the background. There you go. All right, let me get into WebGL. Like probably the topic that no one really understands. Does anyone actually understand WebGL? No, nobody. I didn't think so. So when I yeah, so I spent literally a month looking into this when I told Carlos I was going to do this talk, and I still don't understand it quite honestly. So even after a month of looking through it, you have to have like an actual background making 3D engines in C and C++ to get a really good grasp on it, because WebGL is based off another standard called OpenGL. Yeah, so you've heard of it. Yeah, it's for rendering. I wouldn't worry too much about that, but let me give you like the high level overview, like the super layman explanation without going into all the nitty gritty details. So WebGL is a JavaScript API that enables creation and display of 3D content inside the browser using the graphical processing unit. Works in all modern browsers, but it's a low-level API. you have to write hundreds of lines of code just to do something like a triangle on the screen. So it's not really rational for most people to even touch it. And who here is familiar with a graphical processing unit? That word.
GPU.
GPU. What is it?
Graphics card.
Okay.
It's specifically just for rendering stuff on your screen.
Yeah. So if
Does all the math for me and stuff go on the screen.
yeah, it does all the fancy math in the background. But if you play video games, you definitely want a good graphics card. If you do any video editing or do any simulation work, you're going to have a nice graphics card to run heavy, intensive programs to calculate and render things on the screen. So let me just go over an overview of just how it works and like the very, very most layman explanation by kind of telling you how a web browser works. That way I won't lose anyone in the process of explaining this. So you have a computer. Let's say this is my computer right here. This client computer, right, is this computer right here, right? And you can connect to the internet through domain name servers and also through your ISP. And then you connect to whatever site you're going to, right? Let's say it's facebook.com. And you send the request over from here over to facebook.com, the HTTP request, saying, hey, I want to load the content from your site. Can you show me the site? And then Facebook would say, okay, here's all the stuff back to you, and it'll send you back data, right? And the data that you get back is in the form of, I don't know what happened there. The data that you get back is in the form of HTML, CSS, and JavaScript, and also images too, and GIFs and videos and whatever that loads on your browser, and that's what you see on your screen, right? But WebGL, it still plays off of that. You're still getting data back from the server, but it's a little more nuanced in that. So you're getting your HTML back, you're getting your CSS back, and then you're getting JavaScript. But in that JavaScript file, you're also calling an API, the WebGL API. And in that WebGL API, you have something called GLSL, which is like a C language that communicates to your actual graphics card, right? And this is kind of why people don't understand it that well. This is like the best explanation I can find online, and actually just of explaining how this all works. So you get your files back from whatever page you're looking at, and your JavaScript file is calling WebGL to call this thing, and then that's what your GPU sees, your graphics card, to render things back onto the screen. And for comparison, JavaScript is just running on your CPU. And to show you what this looks like, the CPU is the thing that's on your motherboard that handles pretty much everything from turning your computer on to handling all the processes to actually make your computer work. The GPU is, again, if you do video rendering, if you do a lot of gaming, if you want to run Crysis back in the day, this is what you would look for. If you want to run a bit mining farm, this is what you also need as well. I don't remember why, but I think it has to do with cryptography. But that's kind of an overview of how WebGL works. So I'm going to talk about Three.js instead, which is something most people can appreciate because it's much more simpler. It's an open source library that abstracts a lot of the complexity of WebGL and makes things easier to manage. And what it does behind the scenes is it does all the math for you. So if you suck at, and to give a comparison of how that works with the same diagram, you just throw a wrapper inside between your JavaScript and your WebGL and your GLSL. And this is what Three.js is. So it abstracts a lot of the complexity away. It does all the hard lifting for you. You just have to define the parameters. So it's going to give a demonstration of what it's capable of. You actually just have to see it in action to really appreciate it. So probably one of the most famous examples is this WebGL water. And like this is a MacBook 2015. It's got integrated an integrated graphics card. I don't remember which one. The benchmark was like 1500, which is pretty low. If you look at GTX 1070 or 1080 or 1080, and now it's like 2060. The benchmark is about 10 times higher. But anyways, I just want to show you that you can actually do cool things on this, and it still runs fine on my computer, right? You get to see actual water physics and water simulations, and you would think this is only possible with something on like your actual computer itself, right? It wouldn't run the browser that well, but it's capable of doing really cool things. And you can actually look up, and you can actually see the sun. Well, you're supposed to be able to see the sun. I don't know why you don't. But you can see the reflections. You can see the ray tracing, and you can just manipulate this ball and do whatever you want with it. You can throw it off screen if you want to. Yeah.
Does it come back?
I don't think it comes back. This is a demonstration of this talk. I mean, it doesn't really matter because I just showed you what it can do. Anyways, as you can see, my computer's having a hard time running this because it's using my graphics card. And you can hear my computer kicking on because it's, really trying hard to run this, and I'm doing too many interactions with this screen to actually.
Pretty crazy that like runs on the phone.
Yeah, and it actually works on your phone too. So if you go to madebyevan.com/webgl/water, you can test it out if it runs on your phone or not. And this is kind of like back in the day when we used to play video games, and you would say, hey, if you're going to run Crysis, it's a good computer, right? I don't know if anyone knows what Crysis is. If you're a gamer, you would know.
I know what you mean.
But basically, it was like an artificial benchmark of saying how good your computer is if you can run this really futuristic game that had ridiculous benchmarks. And you can buy a computer today and see if it runs. If it doesn't run, that computer's not any good. So, my favorite computer. Yeah, so if I turn this off, hopefully it'll slow down. Actually, before I do that, let me just turn off everything. I want to see if it turns off or not. Let me get a drink of water while I'm at it. Yeah, so really, it's interesting. So going back to the other examples, you've got this really cool one. I guess if it's still kicking on really loud, it takes time for the GPU to kick off. But WebGL is great for data visualization. So you can look at different countries around the world, and you can look at the amount of oil is actually being used between those countries and how they're exporting and importing things. And like this fine level of detail, like right here, you can see the actual geographical representation of China. And this is only possible. This is, oh, never mind. I thought this was a touchscreen. Okay, well, yeah, I guess it just animates on its own. But yeah, that's something only possible with WebGL. And you don't want to run these programs for too long because obviously your computer just kicks on really loud, and then it probably kills off, like, depletes your battery really quickly too. So just FYI. This is another cool example. Oh shoot. That's the Renault E-Space. I have never heard of this car before, but it's really cool because you can start up the animation. It's got sound playing as well. And it's just a nice, good visual representation of what WebGL is capable of. So pretty much anything you can do in like a simulation software or like a video game engine like Unity or Unreal, you can actually write your actual assets in that program. So it's much easier to wrap your head around, and then export it off as WebGL. And you can play video games on your browser. So it gives you the ultimate amount of flexibility to do whatever you want. If you want to run VR simulations, you can do it in the browser. And everyone has a browser, so it's great. Also, you can set a lighting as well. So now it's just really dark outside and the lights turn on. And yeah. That should give you an idea of what WebGL is and what it's capable of and how it differs from everything else I've talked so far. You can have rendering of very, very complex data. You can have natural shaders, natural lighting, and all sorts of cool things. So, oh wait. I don't know why I had this here. But anyways, this was supposed to be Dumbledore, you know, from Harry Potter. And then I put an image on top, and I was supposed to animate it so it'd come there afterwards. So just imagine the real Dumbledore's here from that scene. I don't remember which scene this is. If anyone can remind me which scene this is from in Harry Potter. Does anyone know?
If I had to guess, it'd be like the one where he's coming back and visiting him, like pulling him, like it's like episode 5 or so when he's
Okay.
like taking him away for basically for good from his house. From his
Yeah,
own
yeah,
uncle.
that sounds about right. So this is the actual scene right here, right, where they actually do all of the shots, the lights, the camera, the scene, the action. When you actually define a 3JS program, you should really think about this, like, because this makes things so much easier to comprehend. So what you have is a scene, and the whole scene is the whole environment that you're in, right? And then you have your camera. The camera's kind of hard to see, but it's on a mounting rail, and it's right here, I think. I don't know, it's somewhere over here. And that camera has like a processor for actually rendering that data back to the SD card, right? And then you have your mesh, which is basically whatever you're taking a video of, right? I just put Dumbledore here, that way you can actually say he's a mesh as opposed to just saying he's Dumbledore, right? So, and that mesh, that Dumbledore mesh, just imagine this is like a 3D thing made in Blender or Maya or 3ds Max, if you're familiar with those. It's got a geometry associated with it, so he's got like a shape, he looks like a person, right? He's got texture, and he's got a material associated with them. So these two things define the mesh, right? What it's supposed to look like is a red box on the screen, right? And in this red box, how you're defining it is you're defining kind of like in that Dumbledore scene. You're defining the scene first, the camera, and how far away it's looking, like from the nearest point, and then the aspect ratio. Anti-aliasing, the size of how big the actual viewport is, and then you define your materials. So like Dumbledore himself, in this case it's actually a red box. And then you defined, you add that all into a variable, you add that to the scene, and then you can set different parameters associated with it, which is part of 3JS. And the reason why you have to set it a little bit further away from the point of 0, 0, 0 is because your camera starts off at 0, 0, 0. So it has to be away from that point of view. And then add it to the render, which is kind of like what the camera's doing behind the scenes. You animate it, and kind of like in Canvas, you also run the request animation frame update, or a request animation frame, and then the function that you just defined. That way it keeps constantly rendering on the screen. And you can, and to kind of give you a better representation of why you set the position here, let me show you this on 3jseditor.com. So this is kind of the scene that I just described. Make a new file. You can create a box, right? And then you can also add a camera. The camera in this case is a point light. So that camera or that light in this case has to be away from the central point. Like it has to be, they have to have some distance associated with it. That way you can actually see what's on the screen. If that makes sense. Because everything starts off in the 0, 0, 0 position. So something has to be away from it in order to see things. Yeah, you don't want to have it right on his head, because then you can't see anything except his head, and it's all black and yellow. So that's the representation of how it works. And kind of that how I described earlier when you were looking at like an actual scene inside of like the Harry Potter setup. This is how you define it in Three.js. So the render in this case is what's attached, which is associated with the camera, right? And they're linked together. The scene is the entire environment that you're defining, the whole fifth movie, I guess you'd say, when Dumbledore comes out and takes Harry away. I can't remember the exact details of that.
Yeah.
The mesh is Dumbledore himself, or in this case, the box. And the geometry, I didn't really talk too much about, but it's the shape of what he looks like. So I guess you'd say he's a person, right? Oh, I just said it was a box in this case. The material, I just defined it as just a flat color. So just imagine, if I define the material in this case as red, just imagine Dumbledore being complete red. That's what would have happened. And then the lighting, I believed I had that on there as well. Actually, there wasn't any lighting on this. Because the material defined didn't have any effect from lighting, I didn't actually define this. But usually you would, and that's if you're having something that's more realistic and 3D rendering like. So this is just the same example earlier, except you can actually change the different parameters on it. So you can change the X position. Let me just open this in CodePen so you can actually see it. So you can change this in CodePen, right? The different X position, the different Y position, the different Z position. And you can see it's coming toward you, right? And then this is the field of view, just like the minimum distance of how you see that element on the screen, and also the lighting. If you take the light really, really far away, you can see that, right? Can you read that? I guess no one can read that, right? Should have probably made sure you can see it on the screen. All right, yeah, so if you take the light really, really far away, you should just not be able to see anything, and you can't really see anything right now. And if you set the Q position at a different point, you can just render it off the screen, so you don't see it anymore. So that's that. Moving on. Kind of a breakdown. So you define your scene. You define this, which is what I was trying to explain earlier. You define your actual camera and all its properties associated with it. The 75 value describes how far away the first point that you'll see right here. The window without inner width and window without inner height is the aspect ratio, so kind of like the ratio between this coordinate and this coordinate of what you see on the screen. So let's say, to give a better understanding of how this works, if you take your phone and you just take a video shot in landscape mode, your aspect ratio is different from taking it in portrait mode. So that's kind of like how to explain what it is. You got near plane right here, and then you've got your far plane, so how far it renders, as well as the position on the screen, and then all the other data you have to set forth to actually make it work. And then you define your geometry and your lighting. So that was the previous example I showed. Kind of some of the other things you can do with it is you can actually do things in Blender, like a 3D program, and then throw it on the screen. How that works is you just actually have that metadata on either locally or through a CDN, and you just load that data, and it's essentially just JSON formatted points that you load through your actual Three.js platform. Just more examples. Probably I won't cover that if you want to come back and take a look at these later. But the one I showed earlier with the design platform, that's Figma. That's all based in WebGL. And also, if you use Google Earth at all, that's all WebGL. If you use Thingiverse, if you're into makerspace kind of things, and you're looking at 3D models to print off on your 3D printer, I don't know who actually does 3D printing, but let me just show you what that looks like actually. Really quick example right here. You can actually go here, open the model, and you can see all the perspective details on it before you download it and print it off. So that's really neat. It's all WebGL based and all 3GL based, or 3JS based. Does anyone recognize this? What is this?
Just a thing that powers itself with wind or
Yeah, it's a thing that powers itself. So it's called a Strauss piece. It's a wind-powered mechanical movement thing. I don't know what you describe it as. And it's all powered by wind, right? The fan, whichever direction the wind's pointing. And to show you how that actually looks in an animation frame on each of the legs, that's what it looks like, right? So what I did is I actually designed this in Fusion 360, which is a 3D modeling program. If you've ever used AutoCAD or if you ever used SolidWorks, you probably would know what I'm talking about. But it's used often to communicate a lot of 3D CAD specs to designers and engineers, either locally or overseas or whatever. And this is all 3JS based. So one of the cool things that you can do is you can actually take that model that you originally created and you can actually blow it up, right? And you can look at the individual elements, you can pan around the screen, and you can also measure it too, if you want to know the dimensions of one point to another. And like I said, this is all possible with 3JS. If you want to, there's another library called Pixie.js, which is really more. It's also WebGL based, but it's more 2D based. And probably the best example to show you is just loading on the screen so you can see it for yourself. This is all WebGL as well. To create this in Canvas or SVG is really, really difficult. The unique animation, the unique feel to this site. You can actually click on the menu and it has like this waving arm that comes up and brings the actual page on the screen. This is all possible with WebGL. So I don't know how you would do it any other way. You could use SVGs, but I'm not sure how to rationalize about that. So really cool. I want to talk about other effects real quick. Things that are not related to SVG, Canvas, or WebGL. So if you're doing web design, a great example to pull up is Amazon. And Amazon, does anyone know how these actual icons appear on Amazon? Like this icon, that, the little cart button, the little menu bar, the logo. How do you think Amazon actually?
Just one image.
One image, yeah, one image. And then why one image?
They used to do that to do it faster, load faster.
Exactly. But why not an SVG? Exactly. There's so many of them. If you're loading a lot of these on the screen, this is something you should know if you're doing any sort of development, even if you're a backend developer, because it relates to performance. I pulled this off the CDN off Amazon. You can see all of the actual assets on the page. Amazon Fresh, different viewport sizes, depending on how, if your screen's really small, if it's really big. They've got responsive media queries for showing which background image to load. And if you did this all with SVGs, the file would be humongous. So essentially my point here is, if you're looking at performance, and you can see Amazon Prime is right here and here. So it's not actually just one image, it's actually two images. If you're looking at for performance and you're loading a lot of like common icons, social media icons, your logo in different formats, you should consider using CSS sprites, which is just one image, and you say, hey browser, load the image at this position. And it's more performance to group many icons over many small SVGs. So, and you can use a tool called SpriteCow to actually make this. You just give it all its images, and then it just spits out a file and says, here, and this is how you load it. And you just go from there. And it's great for e-commerce sites like Amazon. So if you're working in that space or in that field or in any regard, if you're working on a Shopify site or a WordPress site or WooCommerce or whatever, you should know about this. Drag and drop features, just Trello. Just be something to be aware of. You can use something like React drag and drop if you do React development. jQuery UI has a library for this, and that's how that's powered. Different animation effects that you should just be aware of. Parallax effects. You can do this in pure CSS. And the reason why I'm showing you all this is just pretty much showcasing that SVG, Canvas, WebGL is not the only way of doing things. CSS positioning in JavaScript, this is all based on Reveal.js, which is how I wrote these slides. You would think that this WYSIWYG editor would be based on some of those principles, but it's not based on anything. It's just based on positioning in JavaScript. And you can see that also whenever you're shopping online, you're adding custom images to sites. The principle is the same. So just more examples, more food for thought. There's lots of ways of doing things, basically. Just be familiar with how some of how some other companies do things. That way, you just have a better grasp of what's capable. Also, you should probably know this as well. Who here has heard of Font Awesome? Who here uses it? Probably everybody, right? Because you just have so many icons that you can pull up, right? Any size, you can add things like Adobe. I don't know why you would use that, honestly. I'm just seeing what's on the page. You might add the accessibility icon. You might add a menu bar item, right? That's pretty common. Or like an X-shaped button just for after the menu gets clicked. But yeah, this is something you should be familiar with. This is all based off fonts, so it has nothing to do with SVGs, although Font Awesome does have a small section of SVGs they can use. Probably like 5 or 10% of it is SVG based. And also emojis. Just consider emojis. You can just get away with just writing an emoji. Just note that any Windows 7 users using emojis will actually won't see the same emoji, so it kind of changes the look and feel of your site. Because I have a Windows 7 PC, it doesn't work on half the sites I go to. Kind of in summary, what I want to talk about now is, now that I've talked about all these things, I kind of want to talk about, if you're deciding to use any of these technologies today, which ones should you use and why? It really just depends. And also, check for edge cases first. So, first thing you should think about is whether you need WebGL. You probably don't. Most people don't, and that's why no one knows about it. So, putting that out there, just consider that first. If you're building something like Google Earth, which you're probably not. Canvas is great as well for many smaller projects and physics demos. Consider that if you want to showcase how some math works, or if you're showcasing how things are drawn on the screen. Just consider all the other effects that I just talked about, that I just showcased. And then, if all of that fails, you go with SVG, because SVG can do everything. And all the expert front-end developers, or kind of like the developers paving the way for future technologies, they're pretty much all over SVG. So when in doubt, use SVG. And the only downside of using SVG is you have to be good at designing, which I think only 2 people here design. But if you have a designer you work with and they're good at designing, you can pretty much do anything. So yeah, that's pretty much it. The cons of each of them, native WebGL has a lot of boilerplate, it's a little complex, it requires tooling, you have to use a library. Canvas has the least number of options. SVG, if you have too many SVG icons on a page, it gets complicated. And then more information, I think I'm just going to skip over it because kind of the talk is going too long anyways. More stuff I looked up. Yeah, just a lot of examples. I'm just going to ignore all of it. Any questions?
We can post the link to the talk later to the video, right?
Yeah. Yeah, sorry, it was longer than I thought. I didn't do a dry run at all. I didn't know how long this will take. How long was that? It was like an hour and a half, actually. Sorry. Okay, so does anyone have any... Does anyone have any questions?
Trying to think of a good one for Canvas because I'm doing a game in it right now.
Really? Okay, ask. I'm not an expert on Canvas, but just ask me whatever.
Yeah. I'm trying to build a multiplayer game with Canvas and React. Is there any have you ever built anything in
Nope,
React
never.
with Canvas?
I know that there's a popular gaming library called Phaser.
Just to make sure I'm not going to run into
Phaser is really good if you're building a lightweight video game. That's based off Pixie.js, which is like that little thing I showed earlier with the with this page, the one with this cool reel, right? Phaser.js is based off of that, and supposedly if you're trying to develop a game for the first time, it's the easiest platform to work with. and people use it all the time for gaming hackathons because you can learn it in a day. So it's just something to note of. There's a lot of tutorials online for this library. Any other questions?
I can so what I have
Yeah, if you want to put a demo up there.
a little bit of a.
Is it live? I could just go type it here.
I don't have it live right now. No,
Oh, I guess we're doing lightning talks anyways, right?
Well,
Is it?
yeah, I kind of ran out of time.
Sorry.
okay.
Sorry, we gotta wrap it